All right, so now we're going to try a 3x3 system of equations using Gaussian elimination. Okay, so over. Okay, so let's say we had this system. So x1 minus x2 plus 2x3 is going to equal 4, and 3x1 plus 2x2 minus x3 is going to equal 3, and 2x1 plus 3x2 now minus x3 also equals 3. All right. Now, when doing Gaussian elimination on a 3x3 system, a lot of times we don't want to you don't want to write x1, x2, x3 on every single step of the problem. It just drags the process out, okay? So what we're going to do is we're actually going to write this as an augmented matrix so that we don't have to repeat the plus signs or the x1, x2, x3. So if I write this as an augmented matrix, what is this going to look like? Is this 1, -1, 2, 3, 2, -1, 2, 3, -1. And what I mean by augmented matrix is we're just going to draw a line right here. And we're going to draw the right-hand side of the problem. That way we get rid of all the x's and all the equal signs. Okay? So, we are going to be doing this throughout the semester, this type of operation that I'm going to do. But what I'm going to do is I'm going to eliminate the lower triangular, well, not the entire lower triangular, lower offset triangular set. And so what am I going to try to do? I'm going to try to eliminate first this guy, then this guy, and then I'm going to move over. And once I've done that, I'm going to use this component right here to eliminate whatever is going to appear right there. Okay? You use the top row to eliminate these two elements. But once you've done that, you cannot use the top row again. Okay? Because if you tried to use the top row to eliminate this element right here, what would you do? You'd be filling in this spot right here. So we're just going to go ahead and we're going to use the top row, start going down and doing our eliminations. So the first thing I want to do is I want to eliminate that 3 right there, okay? So since I want to eliminate that 3, what I'm going to do is I'm going to take the top row and I'm going to multiply it by -3 and add to this row. Okay. Let's go down a bit. Okay, so the top row is actually not affected by this. We're just going to leave it alone. Okay, so what we want is a 0 right there. And then this is 2, 3, -1. Okay. And, all right, so the top row and the bottom row are not going to be affected by this operation. The middle row is going to be affected by this operation. Okay, and so if I take the top row and I multiply by -3, so -1 times -3 would turn into a +3. A +3 plus 2 is a 5. Okay, so top row multiplying by -3, so -3 times 2 is a -6. Well, a -6 plus a -1, that's a -7. Okay. Now, 4 times -3 is a -12, and then a -12 plus a +3 becomes a -9. All right, now we're gonna take the top row and we're gonna use the top row to go down and eliminate this component right here. So to eliminate that 2, what we're gonna do is we're gonna take the top row, we're gonna multiply by -2 and add downwards. Take the top row and multiply by -2 and add downwards, okay? So, once again, the top row is not affected. The middle row is not affected. It's a -9. Okay, but the bottom row is going to be affected. So we're going to have a 0 right there. Okay. Now, this top row multiplying by -2, right? So -1 times a -2 turns it into a +2. And the +2 plus a 3 is a +5. Okay. Now, -2 multiplied by this row, -2 times 2 is a -4, and then a -4 plus a -1 is -5. Okay. Now, top row, 4 times -2 is -8. -8 plus 3 would be a -5. Now, what I want to do is I want to take this middle row. See, because I can't use this row to eliminate this 5 right here, because if I multiply this guy by 5 to turn into a -5 and I add downwards, it's going to put a 5 right there. And I want to use the top row just to eliminate the zeros below it in the first column. And then I'm going to move over to the second guy, and I'm going to use this 5 right here to eliminate that 5 right here. So to do that, I need to multiply this 5 by -1. And add downwards. So, we take the middle row and multiply by -1 and add downwards. Run out of room on that page. Okay. So, 1, -1, 2, so augment that, 4, 0, 5, -7, -9, 0, and 0. Okay, so now if I take this row and I'll multiply by -1, so -7 times -1, that's a +7. So a +7 and a -5 turns into a +2. And -1 times a -9, that's a +9, and a +9 and a -5, that would be a 4. Put that bracket on. Okay. And I can see somebody's asking questions. Wait till I finish this video, and then I'll answer anybody's questions. Okay, so the point of this is that you are eliminating x1 and x2 from the problem so that you get to just what is this last statement right here? This last statement says that 2 times x3 equals 4. Well, let's write down all these statements. Okay. So these are the 3 statements that we get from the Gaussian elimination, okay? So what we can do from this is we can actually start at the bottom. I mean, I wrote them backwards, but this is where we're gonna start at. We're gonna start at 2x3, which equals 4, okay? So from that statement right there, okay, so these are the three equations that we derived. And so the first one is going to give us that x3 is going to equal 2. Okay? And then the next statement is going to give us that 5x2 minus 7 times 2 equals negative 9. Okay? So that statement means that 5x2 minus 14 equals negative 9. Well, let's add 14 to both sides. Okay, so 5x2 equals 5, or that x2 is going to equal 1. Okay, so so far we've solved for x3 and x2, and now we're going to use this equation right here to solve for x1. Okay, so what's this last statement? That is that x1 minus 1 plus 2 times 2 equals 4. Well, 2 times 2 is just 4, so if we subtract 4 from both sides, we get that x1 minus 1 equals 0, or that x1 equals 1. Okay? And so that gives us the point 1, 1, 2. Okay. Now, once you've gotten to this point of the problem, what you need to do is you need to take this point and actually look back at the original equations that we were dealing with and ask yourself the question, does 1, 1, 2 satisfy these equations? Okay? So let's look all the way back at the beginning of the problem. And what we're going to ask is, does 1, 1, 2 work? Okay. All right, so think about it. If I plug 1, 1, and 2 into this top one right here, what am I going to get? I'm going to get 1 minus 1. Those cancel each other out. And then 2 times times x3, which is 2. 2 times 2 is 4. Cool. And so for this one, you need to check all 3. And so 3 plus 2 is 5. And then 5 minus 2 is 3. And so 2 plus 3 is 5. And then 5 minus 2 is also 3. So this set of points, they do satisfy all 3 of these equations. Okay?